This is numbers 9 through 12 on the Unit 1B Quiz Study Guide. So again, we're going to start by graphing this. This time we've been given the equation in intercept form. So we're going to start still with the vertex. There's a little catch though, because we got to find something else before we can find the vertex in this form. We're actually going to start with the x-intercepts for this particular problem. So we're actually jumping straight to number 12. If you get it in intercept form, go ahead and find your intercepts. So remember, we want to take this and set it equal to 0. And we want to take this factor and set it equal to 0. So if I add 2 to both sides, x is going to equal 0 plus 2, which is 2. So the intercept that goes with that point would be 2, 0. And then we do it again here. We subtract 6 from both sides. So now 0 minus 6 is negative 6. So the intercept here would be negative 6, 0. So my answer to question number 12 for my x-intercepts, or those zeros or the roots, would be these two points on the graph. Now, to find the vertex, remember, the vertex is actually going to be the average of these two. So 2 plus negative 6 divided by 2. So you're actually going to do a little math here. So we want to take the x parts, or those x roots here, and add them together. So 2 plus negative 6, we're finding the average of those two numbers. So 2 plus negative 6 is negative 4 divided by 2, which is negative 2. So the x part of my vertex is negative 2. Just in case you're not sure, you can always go back to your table and verify, and I'll show you how to verify here. So we're going to clear out the function after we go to table. We put in a negative, don't forget the negatives in the parentheses, x minus 2, close your parenthesis, another parenthesis, x plus 6. And push enter a whole bunch of times, and let's go to where we have negative 2. Look at the calculator. You see at negative 2, you see how the values repeat. We know for a fact that we found the right number. So it's actually going to be at negative 2, 16. And then we're going to go 2 numbers to the left and to the right of this. So I've got negative 3 is a 15, and I've got negative 4 is a 12, which makes things a little more complicated on our graph, just because we have a small graph here and it's not exactly going to fit. So either pull out a piece of graph paper and you can go up to these numbers, or you can do what I'm going to do, and I'm going to rescale the y-axis. I'm going to count by 3s on the y-axis. So that's 3, 6, 9, 12, 15, 18, and then the same would be true going downwards. And then the x's, I'm still just going to count by 1s. Those fit nice and pretty on the graph here. So 1, 2, 3, 4, and so on. So what we're going to do, and we're going to go backwards if you need negative 1, negative 2, and so on. So plot your point negative 4, 12. So we go to negative 4, 12, which would be right about here since we're counting by 3s. Then we're going to plot negative 3, 15, which would be here, again, since we're counting by 3s. Then we're going to plot negative 2, 16, which is just above that. And then we're going to plot negative 1, 15. And we're going to plot our last point, 0, 12. And so we've got our parabola. This one's going to be facing upside down. I kind of missed, let's see, 1, 2, 3, 4, 5. I should have gone a little bit more to the right here. 6. All right, so it says, what's the vertex? Vertex is that point where it changes direction, which would have been at negative 2, 16. And then the axis of symmetry, remember that's going to be that invisible line right here that it would fold the parabola in half. And that's an x equals line, and x is equal to negative 2 here. It says, what are the domain and range? Remember, domain is all the possible x's, so the smallest x we can possibly have, if this forever goes to the left, would be negative infinity. The largest possible x we could have, if it goes forever to the right, would be positive infinity. And then the range does have a little bit different of a thing, and this is a good time for me to point out. Remember, when we state these, it's always got to be the smallest to the largest, the smallest number to the largest. So the smallest value that our y can be is way down here, which means we start with negative infinity. And it goes to the highest value here, which would go all the way up to here, which we found to be 16 from our vertex. And it can actually hit 16, so we're going to use the box bracket on it. So there are your domain and range for this problem.